Hey guys, nice and easy lesson today. We're talking about the zeros of a polynomial. So we're going to be using Desmos. It's going to be easy peasy. So the points at which the function intersects the x-axis. That's what we're looking at. That's a zero root solution. Same thing. A polynomial in degree can have n real zeros at most. Could have fewer, but at most it can have is whatever its degree is. An even degree has an even number. So it could have 2, 4, 6, or even 0 real solutions. An odd degree, on the other hand, has an odd number of zeros, so it always has at least one real solution. So we're going to graph this and identify its zeros. Let's do it. Pop it in Desmos. Type it in. Oops. Shut out caps lock on. Here we go. So all we're looking at is the graph of the function and its zeros. So I'm going to go ahead and we get all of these critical points and I'm going to plot them. Okay, -2, 0. -1.2, 2.1, 2.1, somewhere around there-ish. 0, 0. 0.5, -0.6. So about right there in the middle. 1, 0. So that's my 5 critical points I got, starting down, going up. Sketch it, doesn't need to be perfect. Something like that. Beautiful. So there's the graph. Now let's look back at Desmos. The zeros are the x-intercepts, so I just gotta click them. There they are. -2, 0, and 1. The intercepts themselves are the x values. I could ask for it as an ordered pair or just general. We're going to go with the x values only. -2, 0, and what was it? 1? 1. Okay. That's it. Nothing much to do there. Now we're going to use, we're going to go ahead and do this one also, but we're going to use those in a minute. Long way, sorry. -x to the 4th plus 4x cubed minus 2x squared minus 4x plus 3. There we go. So notice it's an even degree. It's got 1, 2, 3. Interesting. How does it have 3? Well, this is actually 2 of them right here. It's a double root. So it might look like there's only 1 root here, but there's actually 2. We're going to talk about that next week with multiplicity. But our zeros, we have -1, 1, and 3. -1, 1, and 3. So if we're talking about the number of zeros it actually has 1, 2, 3, 4. We only see 3 of them because one of them is the same as another. Okay. Let's see. That's bad. 1 second. So now we're going to use those zeros to write a function factor form. not to write it in factor form, but it writes linear factors. So, you probably can factor this one. This one's nice and easy. Just take out an x and use quadratic formula, synthetic division, whatever. We're actually going to do that in a second, but let's just graph it. Let's see what happens if we graph this thing. X cubed minus 2x squared minus 15x. And let's look, what are our zeros? -3, 0, and 5. So x equals -3, x equals 0, and x equals 5. Yes, I don't like that for a reason. We're trying to find our factors. Remember, whenever we're factoring, we looked at our zeros and then went backwards. We solved them for 0. So it makes this 0 x plus 3. X, well, that's already equal to 0. And x minus 5. And that's our factors. We already did this. Usually if we just have an x, we'll stick it up front. Don't have to, but I like to. And now this polynomial is factored based on its zeros that we got from its graph. Now, a lot of times, you won't have necessarily very nice zeros. So what you're going to do is you're going to graph it. And let's say, yeah, I can't make it off the top of my head, sorry. Maybe? Yeah. Let's just say, for some reason that this was a nice one, but these two were nasty or something. What you would do, all you'd have to do is take this one. So let's take this function again. And we're going to use synthetic division with it. So x is -3. Since it's cubic, if we break it down to a quadratic, we can use the quadratic formula on it, multiply 3, and we'll have all of our exact roots. So if it's cubic, I just need 1. If it's 5th degree, well, I'll need 3 of them. So you have to use your graph to find 3 of them. But you're going to find how many you need from your graph, and then you can use synthetic division to break it down. 1, -2, -15, and 0. Go to the refresher here. 1, -3, -5, 15, 0, 0, and 0 is our remainder. This is also 0, by the way. Let's come out 6. So we get, if you remember, it's going to reduce the power by 1. So 1x squared minus 5x plus nada. Solve this thing, quadratic formula, however the heck you want to. I'm just going to factor it. X minus 5, x equals 0, x minus 5 equals 0, x equals 5. Also taking the calculator. 3, 1, -5, 0, 5, and 0. However you gotta do it, doesn't matter. But those are our zeros. This could be some square root kind of things going on if we use the quadratic formula. Didn't have nice factors, if possible. So that's how you can factor it. Just get your zeros and work backwards, just like we did in the past. So again, that's a short, easy lesson today. See ya.